So yesterday our focus was the discriminant. We're going to review it, make sure we totally understand it. And then today we're going to introduce the quadratic formula. So a lot of you, like you said, you did your project back in 8th grade on quadratic formula. A lot of you have already seen the quadratic formula. But that's okay. We're going to review and go back through it today. So, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's adding what we did yesterday and then a new step.
Are we gonna have to like memorize that?
Yes.
Oh, that. Can you give it to us on the board?
Quadratic formula.
Oh my God.
So this is going to make you memorize it. Ready? This little tune is never going to leave your head. You're going to listen to it once. Every time you do the problem, you're going to say it like this now.
I bet I could remember.
So, ready? The quadratic formula is
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
This is making me literally a little bit nervous. I don't want to watch it.
That does sound like you.
I thought that was you when first started playing.
Say cancel.
we want that tune in mind.
I forget to do it already.
Pop goes the weasel.
I don't forget to
do
do
it.
it. I don't
Negative
know
b.
negative.
Ready to play it again. Maybe at the end. Alright, I'll play it at the end. AOS. Do you remember what the AOS was? Axis of symmetry. So if you go back and you think about a quadratic function has an AOS. It's the line that cuts the quadratic function in half. It goes through the vertex. So essentially the AOS is the front part of the quadratic formula. The other part, this part here, the discriminant, is that distance away to both our roots. So what the quadratic formula is doing is finding us these two values over here. That's what it does. Yes?
The AOS is 2a?
Negative b all over 2a.
Negative b all over.
Yeah.
Okay, quadratic formula must be in standard form in order to use our new formula. Quadratics must be in standard form in order to use our formula. So you have to go ax squared plus bx plus c. We will identify the a, b, and c, and that's what we plug into the quadratic formula. Yesterday we focused on the discriminant. We're going to review what the discriminant does and why it's important. So remember, the discriminant is always b squared minus 4ac. So, why do we use the quadratic formula? Well, the quadratic formula will solve any quadratic equation. We'll solve any quadratic equation. We saw with factoring, if it wasn't factorable, we wrote prime. Now you wouldn't write prime. You would use the quadratic formula and get your solutions. Under the square root of the quadratic formula is that important piece called the discriminant. The discriminant we saw yesterday told us the number and types of solutions. So again, the discriminant is under the radical. It's b squared minus 4ac. Our primary focus of yesterday's lesson was the importance of the discriminant. So reviewing that, the discriminant told me the number as well as the type of solutions. Another word for solutions is the roots. Sometimes we call them the zeros. We can also call them the x-intercepts. Yeah.
So on the homework, I kept writing 2 imaginary roots. Would that be marked wrong, or can I say that?
That's the same thing.
Okay, good.
Okay, what do we look for? Well, we look for the discriminant to be positive, 0, or negative. And then that determines the number and the type. We're going to reiterate what the numbers and types are. So again, the discriminant tells me the number and types. If I get a positive discriminant, I get 2 reals. If I get a positive perfect square, we say that those 2 reals are rational. If I get a positive perfect square, it actually meant that the quadratic was factorable. So 2 rational reals means that it was factorable. If you get a 0 for the value of the discriminant, it is 1 real. That real will be rational. And that solution will be the vertex. If my discriminant is negative, then I have 2 imaginary solutions. Questions at all on any of that? So that's kind of yesterday in a quick review. Yeah. In a show. So, when looking at quadratics, we want to follow a set of steps. The first thing we want to do is make sure our equation is set equal to 0. So in example number 1, it's currently set equal to 11. We need to move that 11 to the other side. So by subtracting 11, we get it set equal to 0. I want to make sure I know what my A, B, and C are. So A is positive 2, B is positive 7, and C is negative 11. I want to determine the value of my discriminant. So remember, the discriminant is b squared, always subtracting 4 times the quantity of A and C. So we have 49 plus 88, which is 137. 137 is a positive, non-perfect square. So it's a positive value. So I get 2 solutions because it's positive. And my solutions are going to be irrational reals. The new step is simply plugging into the quadratic. So all we're going to do is say x equals now the opposite of b. So b was positive 7, so this will equal negative 7. You always incorporate the plus minus between them. We're adding a radical. Underneath the radical is my discriminant value. If you already found the discriminant, just write it. Don't do all that math underneath there now. So the discriminant's 137. The negative 7, the plus or minus, and the 137 all go over 2 times A, which was 2. So this is the same as negative 7 plus or minus 137 does not simplify. 2 times 2 becomes 4. That is your answer.
All that.
All that. You do not need to tell me the decimal. You do not need to try to divide 7 and 4 because they don't divide each other. Now, we're going to look at some other examples where 137 can be reduced. Or we're going to look at examples where this is a perfect square, so it can be reduced. So there are cases where we do simplify. So that's why we have 4 examples today, and not just 1. So let's look at example 2.
Thank you.
We got x squared plus 2x equals 63. Step 1, set it equal to 0. So how do I set something equal to 0?
Subtract 63.
Perfect. Make sure I know my A, B, and C. So A is always on x squared, B is always on x, and C is the number by itself. So we have 1, 2, and negative 63. Finding my discriminant, it's 2 squared minus 4 times 1 times negative 63. Positive 256. So that is a positive perfect square. So if you have a positive perfect square,
2 rational roots.
perfect. Now, plug into quadratic formula. So the square root of 256 is it's negative 2 plus or minus 16 all over 2. This is the case where I have to split my workup because I'm going to split the plus or minus. So I'm going to make it negative 2 plus 16 and negative 2 minus 16. And both of them are still divided by 2. Negative 2 plus 16 is 14. 14 divided by 2. Negative 2 plus negative 16 is negative 18. Negative 18 divided by 2 is negative 9. So really, like what we're saying is x equals 7, x equals negative 9. These are my roots, or my solutions.
How did you know that you needed to put that over
because the formula is all over 2a.
How do you do like when you split them? Like how do you know if you
So all we do is we take the numerator, which has the plus or minus symbol, and you put positive on top, negative down here, like when you split it, and then the denominator has to follow both.
is that only if it's a perfect square?
Correct. So let's look at example 3. You have x squared minus 5x minus 24 equals 0. Our discriminant will be b squared minus 4ac so what's my discriminant end up becoming? I heard it. Yeah, 121. What do we know about 121? Yeah, it's a positive perfect square. So that's 2 rational reals. So you get x equals negative b, so in this case a positive 5, this is negative, plus or minus square root 121 all over 2 times 1. The square root of 121 is really, so you get 5 plus or minus 11 all over 2. So when you get those two real numbers in the numerator, you got to split it. So it becomes 5 plus 11 over 2 and 5 minus 11 over 2. Because that's really what the plus or minus is saying. It's saying you take the b value and you add to get one side, then you take the b value and subtract to get the other. Because remember, a quadratic is symmetric. So 5 plus 11 is 16. 16 divided by 2 is 8. 5 minus 11 is negative 6. Negative 6 over 2 is negative 3. So again, what this says is if I were graphing this, this quadratic would have a point at 8 and negative 3, 0. Go back to graphing. The a value is positive, so it opens up like a smile. The middle of those two numbers will be your AOS. So that's like right here. So there's your quadratic. What we are doing is finding those roots or those points that hits the x-axis. Last example. Add over the 13. Find your discriminant. So we get 36 minus 52, or a negative 16. A negative tells me what? And here's why a negative discriminant is imaginary. Let's plug in to the quadratic formula. What do you know about a negative under a radical? Exactly, it becomes an I, and then you simplify the numbers, and square root of 16 is 4. So this becomes negative 6 plus or minus 4i all over 2. do not try to divide the 2 into the 4 or the 6. It has to divide into both or none. Both or none. You can stop right here. If you want to get fancy, you got to take a 2 out of the top. And then you can cancel that 2 from the bottom. But you got to take it out. You cannot just take it from one. It has to come from both.
Do I ever have to do that?
No, so I said, you don't have to do this. But this is why you can't just take it from one and not the other. Like it has to come from both. We have a tendency to just be like, oh, that's -3. Plus or minus 4i, and that is not the same.
But it was the same. Oh, wait, never mind.